Okay. Moving on to section 10.3a here. We are talking about operations now with radical expressions. And so really today, we're going to break this one into a couple different days too. 10.3a, we're going to focus on adding and subtracting of radical expressions. And then a lot of it's going to be similar to what we've done in 10.2a, or in 10.2, all of those sections, where we have to simplify some things and go from there. But when we talk about what like radicals are, they have the same radicands. And remember, radicand is the number underneath the square root sign, or underneath the radical, as we call it. And then we basically use the same method to combine like terms as we do with monomials, meaning that you add the coefficients basically and keep the variable the same. In this case, we're going to add the coefficients and keep the number underneath the radical, the radicand, the same as well. So here's some examples here. You can see that we can combine these like terms because they both have an x. And so to do that, we would just add up the 3 and the 6 here to get 9x. Okay, the same deal is done with radicals, radical expressions. So they both have this square root of 2, so we would just basically take the 3 and the 6, add those up to be 9 times the square root of 2. Okay? So that square root of 2 just kind of acts like your variable. All right? So let's go on to talk about how we do it, to add and subtract. All right? The first thing we're going to do is combine the coefficients of like terms. So if you have like terms, you can combine those coefficients by adding or subtracting those. And then leave the radical and radicand alone. Don't touch it. Don't do anything with it. Don't add those up. A lot of people make that mistake. They're going to add what's underneath the square root. Don't do that. Okay? So let's fire away at some examples here. Let's go to example 1. Okay, so in this one, we've got a couple things with a radical, and we've got a couple things that don't have a radical. But the ones with the radical have the same radical, so we can combine them. So we just look at what they've got here. We've got a 3 times the square root of 7 here, and a 5 times the square root of 7 here. So together, again, we're just going to leave the square root of 7 alone. That's going to act like our variable. We're going to add up the 3 and the 5. And we can because we know it's a plus sign here and a plus sign here. So 3 and 5 would give us 8. And then we bring that square root of 7 with us, so it's 8 times the square root of 7. Okay? And then we still have to combine the other two terms, as we've got a 4 here and a 6 here. Those are like terms. They're just constants. So 4 plus 6 gives us the 10. So we have 8 times the square root of 7 plus 10. Now, I usually write the numbers in front of the radical expression. So I would go 10 plus 8 times the square root of 7. But you can write it the other way as well. Okay? Let's look at example B. If we look at example B, you can see that these radicals, we've got a square root of 3 and a square root of 6, they don't match. Because the radicals don't match, we can't combine them. Okay, can't combine them because they don't match. All right, and now let's look at, say, example C. All right, this one we've got a cubed root. Okay, it's the same deal as long as the roots are the same, or the index we called it, right? Over here on A and B, we're using square roots. Here we've got a cubed root here and here. Because they're the same, they're both the cubed root of xy, we can just add up what's outside. So we've got 8 here and a 14 here. 8 plus 14 gives us 22. And then we would not touch the radicand or the index. It would become the cubed root of xy. And that would be our final answer there. Okay? So simple stuff there, adding it up. All right, next up, how about simplifying before adding or subtracting? So sometimes there's going to be a case where we have a square root of something that is a bigger number that we can break down first. So we're kind of combining what we did in 10.2, simplifying them before we add or subtract them. So the first thing we're going to do is simplify each radical. So we know how to do that from 10.2. You're going to break it down into factors. One of them, which is a perfect square, and take the square root of that, break it down. Then you're able to combine like terms. okay? Just like we did in the above examples. Okay, so let's do a couple examples of that. Let's look at example A here. All right, we've got the square root of 50. So the first thing I'm going to do with the square root of 50 is I want to break that down, okay? So I need two factors that multiply to make 50, one being a perfect square. All right, so we know that one could be the square root of 25 times the square root of 2. And therefore, we know, again, that we can go ahead and say, well, the square root of 25 is 5, so that one breaks down to 5 times the square root of 2. Let's go to the next term. Let's go to the next term. We can go ahead and say 3 times the square root of 32. Well, let's break down that square root of 32. We're looking for perfect squares. Okay, so to do that, we know that we can break this into, I think 16 works. 16 times the square root of 2. Right, 16 being the perfect square. So I can cancel that out and make that 4 times the square root of 2. However, we're not quite done because we still have this 3 out here that we have to deal with. So with that, we take the 3. What are we going to do with that? We're going to multiply it times this 4 to get a 12 times the square root of 2. Okay? Okay, so now we multiply that 4 times the 3 to get 12, but what sign goes here? Well, because it was a plus here, it's going to be a plus there. All right, now the last one over here. We're going to break that square root of 18 down, and I would use, say, 9 and 2, because those are perfect squares. Square root of 9 times the square root of 2. And we know that the square root of 9 breaks down to 3 times the square root of 2. And so we're almost done, but again, we can't forget that we've got this 3 here, and we got to multiply it by that 5. So 3 times 5 is 15, so it'd be 15 times the square root of 2. But now, be careful with that sign. What sign goes here? It's a negative 5, so it'd be a negative 15. Now we have everything with the square root of 2, so now we're combining like terms. We're going to combine this 5, this 12, and this 15. Well, 5 plus 12 is 17, minus 15 would give us 2 times the square root of 2. So again, we kind of treat that radical and the radicand as a variable, all right? All right, let's skip over to letter D here, okay? All right, letter D just gives us a little more practice with this. Square root of 24. So the way I'm going to break this one up is say the square root of 4 times the square root of 6, because I know square root of 4 is perfect. So that's going to become 2 times the square root of 6. And then 54. You got to be careful with 54. I think 9 and 6 work. Right? Square root of 9 times the square root of 6. And again, we're going to take that and make it 3 times the square root of 6. And again, just check that sign. We got a negative sign there, so it's going to be a negative 3 times the square root of 6. And the last one, 96, you got to be careful with what works, but I think it's 16 times the square root of 6, I believe. Yep, 16 times 6 gives us 96. So square root of 16 times the square root of 6 will give us the square root of 96. And then I know that square root of 16 is 4, and then it'd be 4 times the square root of 6. And this is a positive over here because we keep that sign positive. So now we've got a 2 times the square root of 6, a negative 3 times the square root of 6, and a 4 times the square root of 6. So because those are all the same, I can add up my coefficients. And 2 minus 3 is negative 1, plus 4 is 3 times the square root of 6. That's my final answer there. All right, that does it. That's all there is to it today. So our lesson summary here is how do you combine like terms when working with radicals? So here's an example. How do you combine those terms? And then the practice problem here is to combine like terms. 2 times the square root of 125 minus 3 times the square root of 80. So to break those down first, I would use 25 for that first one, and I'd be looking at, say, 16 for the second one. So those of you that don't listen to the audio, I just gave you a really good hint that you're going to miss out on. Okay? All right, thanks a bunch, and we will see you later for 10.3b.